Welcome again to another episode of the Sustainability Podcast. Today, I'm thrilled to be joined by Pamela Hamblin of Select Power Systems, which is a nationally renowned engineering firm focusing on the energy industry. It's also woman-owned. So, Pamela, it's great to have you here today. How are you?
Yeah, I'm so good, Jim, and thank you guys so much. Art Consulting for having me on here. I feel like there's so much about energy that I just want to shout out to the world. So I appreciate you giving me the opportunity here to have a little bit of voice in this situation that we're in. I call it a situation. So,
well, again, it's great having you here today. Let's just get started. Tell us a little bit about yourself and how you came to this energy industry.
I ask myself that a lot too. So I have been in this industry for 25 years. So yes, I was like 5 years old when I started. I'm just joking. I've been in the industry for about 25 years, and I spent a good deal of that time working with our legacy facilities, mostly coal and gas. I developed one of 3 programs in the world that tracked risk and reliability for high energy, high temperature, high pressure components within our legacy centralized systems. So I have a real good understanding of the age of those units and where they're standing right now, given the way that they're operating. And then I made a shift a few years ago over to the renewable side, just because I understood the ship was already kind of sailing, that we were going that direction, and we needed to integrate the two, centralized and decentralized, the renewable systems into our 150-year-old grid. So I have a passion for really just getting out there and trying to make a difference, and that's the company I work for. That's what drew me to them. Is one, it's women-owned, and two, and so I think the diversity and inclusion is important in this industry, and the tagline is "Power to Make a Difference," and so that is what we do, and that's what I'm aiming to really make a difference in.
That's great. So we're all making this transition from legacy power sources to renewables. Can you describe your perspective of how that's proceeding, and more importantly, just what's the current status of that energy transition today?
Well, this is where everybody people who are not in this industry, or maybe they're just in a small portion of this industry, so they're not seeing the big picture of it. I'm terrified is what I am of where we're currently at. And I keep telling people this is going to get worse before it gets better. And I don't want to be, negative Nancy on this. It's just, I understand this gap that we're in between, I feel like as a nation, we kind of put the cart before the horse. And so we figured out how to do the generation, decentralized generation, whether we're using solar, gas, thermo, hydro, water, or whatever. Whatever those fuel sources, I call them fuel sources because that's all the coal and gas is too, is a fuel source. So we're now harnessing the fuel source of our earth as opposed to harnessing something that's emitting the carbon emissions. But anyway, we have a severe gap because the transition to get there means we're going from a 150-year-old design system, literally. Our transmission and distribution was designed 150 years ago. And I had, I'm going to elaborate, if it's okay, a little bit on how did I get here. But years and years and years ago, I had the opportunity to visit a town called Bodie in California. And it was one of the nation's first gold mining towns. So it's a ghost town now, totally a ghost town. It's a unpaved road to get there. There's no cell phone service, all this stuff. And when I was touring the town, I was in the power industry, but it was probably, 17 years ago. There was one of our nation's first power generation sources there. And, the generator was still there and the wires were still there. And I was like, I'm looking at the mountains that these wires are going over, and they're going one straight line from the center of town all the way up the mountains, when you could have gone around, around the mountain, up the mountains and over the mountains and down. And I asked the tour guide, I'm like, well, why is this line just, I don't know why it stood out to me, but I was like, why is this just like taking the longest route? And the guy goes, well, 150 years ago, they didn't know power could turn corners. So we didn't know power could turn corners. So we just took the long road. And that's what we're dealing with today, is a transmission, and not so much the distribution, but the transmission lines that are 150 years old. They're outdated, and they were designed for one-way traffic. And we are now turning into a spaghetti bowl of traffic where we've got bidirectional power in multi-lanes that all of the hardware and infrastructure needs to be upgraded to handle, because you can't push power against on itself or you're going to have a problem. So that's kind of what really got my brain moving. Like, we thought power could only go in one line. Well, when has all this been changed? I mean, they did some upgrades with substations and distribution, but in the fundamental point here is that transmission lines are very old and only designed for one direction power. So,
wow. So let's slowly and carefully go through the number of challenges that you might perceive in the industry.
Okay, where would you like for me to start? This is a perfect storm. So let me go back and say, I have presented with ASME in front of Congress as an expert on energy, and that was a couple of years ago, and I specifically asked the question in the room to the Department of Energy, the elephant in the room question, which is, what are we doing to bridge this gap of this energy transition? And the answer I got was, well, we're putting in smart grid technologies. Okay, well, smart grid technologies are great if the line can handle the bidirectional power, right? So when we're looking at a typical coal facility, we're just going to take like a typical coal facility. When we look at energy then versus energy now, so centralized to decentralized, meaning one central place that we're creating all the power and sending it down the transmission and out to the distribution, and it loses power as it's on its little trip, so as it's going, it loses its power. So some of the challenges that I'm seeing is the typical generation capacity. That's what I always call it. Some people call it some different things. Of a coal unit is 500 megawatts. So when we look at 500 megawatts, it's all being produced in one location. And many of those emissions are not there. They've put on scrubbers and they've put all these things on the stacks so that the emissions fall within the guidelines. However, the guidelines keep changing. So they keep trying to put these upgrades there. Now, we're keeping on centralized for a minute and the problem with that. So 500 megawatts was typically designed about 60 years ago, sometimes more. The lifespan of those, the average lifespan of those units with their metallurgical components is 60 years. So many of them have reached their end of life, and they're being operated in a cycling fashion because our centralized units that were supposed to be decommissioned years ago, you unwrapped the whole thing here, just so you know, this is not a short answer. This is the part that a lot of people don't realize. So these units, I like to do analogies. So have you ever driven like a stick shift?
Sure.
Okay. So let's say you live in the north somewhere and it's cold, unlike you and I in Florida. It's cold, so you get snow and that kind of thing. And let's say you're driving like a Volkswagen or something like that, and you left your car out overnight and got snow all over it, and you're late for work. So you hop in the car, you start it up, and you hit the gas and try to go 0 to 60 in like 30 seconds. We all know you're going to crack your block because you haven't given the engine time enough to warm up. If it's a stick shift, you're going to skip like first and second gear and try to just get that guy going in third gear so you can get to speed faster. So essentially, that's how these older units that were designed to just drive from New York to California without stopping, like these old units were base loaded. That's what we call it in the industry, base loaded. So they're designed to ramp up to full speed. It takes about 18 hours for them to go from a cold start to full ramp speed, 18 hours. Now they're expected to go in 30 minutes or less. That's what they need to do in order to fill in the fluctuation of our renewables. So what they're doing, one, is they're reducing the life of the components because it's like driving in a city versus driving on the highway. They're utilizing, ramping this up and down, up and down, up and down more often. So cycles is what we call that. And they're doing it in a much faster scenario than they are supposed to. So they're bypassing a lot of the safeties that are put in place in order to ramp up to get to full load in order to meet the need and the demand on the grid. So the utilities now have a position where they are having to make financial decisions of, we're supposed to decommission these units. They're at end of life. We either are going to invest a lot of money to replace the components that no longer, can be operated safely, or we're going to decommission it. But then we don't have the power, the stable power in place yet. And we don't have the way to get to transmission and distribution because our lines haven't been upgraded or our substations haven't been upgraded, or we don't have the sensors in place. So there's a lot that has to go in to that scenario. So that's where we go with interconnection. This is the second part. You want me to take a breath and you can interject?
Continue. This is fascinating.
Okay. So this all leads to interconnection. Now this gets kind of confusing. There are energy markets that are deregulated, energy markets that are regulated. That is when we basically went to a deregulated market years and years and years ago, where we made all power sources competitive against each other. And we put these rules in place in all of the energy markets. Energy is a commodity in these markets. And I think there's 5 of them across the US. They're divided into separate areas where all of the energy that is generated goes into a pool, and you have to bid in like a daily bid, kind of like the stock market. If you're doing day trading, it's like day trading, but it's power. And so the most efficient power source generation and availability is the one that wins the market bid for that day. If they do not meet that demand, then they are paying crazy amounts of penalties to the market, because then the market has to pull in a secondary resource to do the generation. So obviously, when you've got coal and gas competing in the same market with, solar, wind, water, hydrogen, whatever, thermo, if they're all competing in the same energy market, it's pretty safe to say that the coal and gas are not the first ones that are winning those bids, because they have to bid in. The only thing that they can bid into the market is their response time. They have to be able to respond in 30 minutes. They have to be able to do that several times a day, and they have to be within a certain price point. And the only price that they can include is their fuel price. They cannot include their maintenance. And so the maintenance is getting out of control on some of these old units. So coal is about a 60-year life. Gas is about a 30-year life, although those units were designed to cycle more. They can ramp up faster. However, they have a shorter lifespan. So many of those units are also being slated for decommissioning because, one, the regulations that are out there, and two, they're just at end of life, and it doesn't make financial sense for utilities to go in and do the investments. So that would be the energy markets. Then we look at the interconnection markets, which are different than the energy markets. So while there's 5 energy markets, I think there's 3 interconnection markets. So there's the West Coast, and then there's Texas is their own, because I'm from Texas and we kind of think we're special. So Texas is their own. And then you have the East Coast. So it's basically 3 different interconnection markets. There might be another smaller one that I'm leaving out that's Midwest. But I believe 3 are the major ones. So if you guys recall, several years ago when Texas had those bad storms, I know my parents were without power for several weeks. A lot of that has to do with the interconnection situation. So because Texas is kind of islanded, they're not connected to the other grids for utilizing their power. So you have to go through, if you want to start pushing power back onto the line. So when we're looking at a renewable energy resource, now I'm going to switch over to renewables. When we look at a renewable energy resource, they're normally on the smaller scale. Sometimes we're getting the utility scale, but they take much longer to get approval because the utilities have to go through the interconnection process approval as well. So They're normally something that's on the distributed line, a DER, as opposed to something going down the transmission line. So you have to get in a queue. It's called a queue for interconnection, the queue approval. And with the queue approval for interconnection, that is basically the commission is looking at what's going to affect the transport of energy bidirectionally. What do we have for equipment on the line, like substations that have the switches? How can we control if there's a problem here? We need to be able to shut it off here so that we don't, electrocute people. So they need to isolate where the problems are. And they also need to have sensors for demand control. So, and those are smart sensors. So we start getting into a whole nother issue with this transition is the smart sensors. It's like the new terrorist attack waiting to happen, but I won't go into that right now. So with the interconnection, there is a backlog. There was a report by Berkeley not too long ago. I'll see if I can pull it up to get the exact stats for you. Let me make this bigger so I can. So this was the best report I've seen so far. It's by the Berkeley Institute, and the whole thing is about connecting to the queue. So this was published in 2021. So this is fairly accurate. It's reducing by a little bit, but they're still projecting quite a bit of a queue, if you want to call it a queue, by even 2029. So when you take that into consideration, when most of these goals to decommission these coal and gas units is 2035, but being net zero, the queue is way behind that in order to get these renewable projects into the interconnection process. So in 2021, by the end, let's see, actually, this was the online date by 2024. So these are projects that are in the queue with a total capacity, so generation capacity, has, it was 73%, 998 gigawatts of total capacity are in the queues waiting for approval by 2024. Only 13% of those, 183 gigawatts, so gigawatts much bigger than a megawatt, already has executed internet interconnection agreement. So out of 73% that's in the queue of what we're expecting to come online, only 13% has been approved. And the average wait time is about 3 to 4 years, depending on which interconnection market you're in. So next problem. You want to interrupt me here?
Continue on. You're on a roll.
Okay. So the next problem comes. Most of the people who are building the DERs are developers and IPPs, which are independent power producers. It's not the utility. So the utility is typically the one responsible for the lines, but they're not responsible for the end generation. So if we look at like a microgrid, that's my favorite thing to look at because I think it's an answer to bridge our gap, but we can get into that in a little while. But most of our microgrids are anywhere from 500 kilowatts to 1 megawatt in generation capacity. And those are normally a hybrid microgrid that's utilizing multiple fuel sources, renewable fuel sources and battery storage. So if we're trying to replace one coal unit that's average 500 megawatts with a bunch of little microgrids or some other source of renewable, there's a lot of work that has to go because, you'll get 500 megawatts and we can maybe get 1 megawatt out of a daisy chained microgrid. You can get a little bit more out if you have the land space and you have the funding, and the funding is definitely coming. It's just a matter of getting your hands on it. So when you're looking at the queues, anything over 500 kilowatts in power generation that wants to push back onto the grid a bidirectional power, they have to go through interconnection approval process. So that means if it takes 3 to 4 years, a developer has to carry that project on their books for 3 to 4 years and put the finances and stuff like that out there without a return on investment. Then you got to look at the availability of the resources that you're needing. And I don't know why I'm drawing a blank on that right now, but getting batteries and getting solar panels and that type of thing is very difficult right now with the supply chain. That's the word I was looking for. So supply chain. So there's supply chain issues, and the more that our demand goes up for these supplies, the harder that's going to be and the more expensive it's going to get. So let's say you're a developer and you've put in all of your application, you've spent all of your money, you got everything, the designing, everything good to go. You know exactly how much power you're going to go on. You can isolate it if you need to, all that good stuff. you still got to get in line. It's like waiting in line for a good concert or something. You still got to get in line. So you get in line behind all of these projects. And if any of the other projects fall out of line, like they decide they don't want to carry this any longer, or they weren't approved or something like that. Say there was a large, utility scale project on the queue, but they pulled out for some reason because it wasn't making financial sense or something for them.
Mhm.
Now everybody behind that project in the queue has to go back through the queue again. So because now let's say it was 30 megawatts or something like that. Let's just use the word 30 megawatts of power that was going to be a utility scale power. So it was going to be basically going one directional. They're not looking for a DER. They're just doing transmission, basically just replacing the centralized with a renewable centralized. So let's just say they drop out. Now you got 30 megawatts that was accounted for in all the calculations of the queue that just went out of the queue. So now all the ones that were falling behind that they were accounting for that 30 megawatts in, they have a better chance of getting approved, but they have to go back through the queue. So the queue is a big problem. The interconnection queue is a huge problem, and our transmission and distribution and sensors is a huge problem. And the legacy units are not, unless we start, I know they're bringing back nuclear on a lot of things, and that's good to some extent. Couldn't do that for years and years, but it's clean. As long as nothing goes wrong, it's clean energy, and it can produce a lot of baseload power. So that's that.
Well, thank you for that. That was certainly an extensive answer, and the details were superb. I almost shuddered to ask the follow-up question, but here it is. So how do we as an industry surmount all of those? What are the first, second, third things we need to do to move this industry ahead and actually achieve this energy transition?
Well, I think that we've made good progress in that. We have finally, the government was originally investing a lot of money in generation technologies. How do we generate renewable energy, that's green, and where do we stand on our carbon emissions? And so I didn't even talk about EVs, but that's a whole nother situation that's causing demand surges on our grid. So I think first and foremost, which we have already started to do, is making the grid stabilization a huge priority. Where finances are out there for any company that can do anything with these poles and wires and substations and sensors. One, to keep our power safe. Two, to help with demand control. And three, to absolutely be the crossing guard of like substations, like a crossing guard of which way is power going. Or, if you have traffic on a highway, like one of those, highways where all those cars come together and the traffic lights were out. It's like mom and dad are not home to watch over what's going to go on. So, that's our big thing, I think, is transmission distribution. And then personally, I think a lot of that can be handled by curtailing some of the large energy usage, so some of our manufacturing facilities, hospitals, those types of things, they can put on curtailment because it's business. Energy is business. They're getting hit with these large fees for, I don't know if you, even as a consumer at home, some months your electricity bill is a lot higher than the others. And you're like, well, I didn't use any more electricity, but you went over a certain tier, is what the utilities call them, tiers of charging, of usage. And so if you go over that, your price is like double for just that little amount that you used. So what we're looking at and what we've been doing is peak shaving. We call it peak shaving, like little smaller microgrids that help the facilities just shave off their high usage time, so that one, the utility can predict demand a little bit more, and two, you cut the cost of the user, whether that be, it's most of the bigger like Costco's, Walmart's, universities, hospitals, but you have to have consistent power. And that's where the problem comes. If you look at any kind of intermittency with something that's off grid or even curtailing usage, you have to have the switches in there to be able to say, hey, we don't have wind, we don't have solar, we don't have battery storage anymore. Everything we've been utilized. So now we've got to go back and draw off of the grid. So it's bridging the gap. So that's the reason why it's in my head. So you have to have those sensors in place, and you have to make sure that even the smallest, I'm going to call it a blip in power, but sometimes you get like a little blip in power and it's no big deal to us working from home or something. But when you're in a manufacturing facility, I don't know if you ever saw the I Love Lucy. I try to put everything in something we can remember. Did you ever see the I Love Lucy show where all the chocolates were coming out too fast and they couldn't wrap them up, so they were putting them?
Sure, everyone's seen that.
Okay, so imagine if those were bottles in a manufacturing plant, and all of a sudden you had a blip in energy. So now all of a sudden all of your units are off, and you're either shooting bottles through at the wrong time, and you got Coca-Cola, not going into the bottle but on the side, or your holes are in the wrong place on your plates for your vehicle that you're putting together or something like that. Like if you have a blip in power, even in a hospital, if your generating, situation doesn't pop in, you could lose lives. So power reliability is huge. And that's where a lot of fear comes in using the renewables. So I don't know if that even,
certainly power quality makes me think of even, I know there are indoor farming applications where even voltage drop affects the frequency of light coming out from fixtures, and you get a lower crop yield.
Yeah.
There's innumerable impacts by low voltage, not to mention our microprocessors don't work as well as they should.
Yeah, there's days. And then we look at even communication. That's a big thing we're looking at now too, is being able to drop in like little miniature hybrid. When I say hybrid, that's multiple generating resources. So it, depending on where you're located at, maybe solar might be like Florida. Solar is going to be your tertiary, your number one usage of fuel. And then you might put wind in there. You might put some hydrogen fuel cells, depending on where you're located in the cost. And then you might go over to some battery energy storage. Well, you definitely have to have the battery energy storage on that. And then with that, throwing in a telecommunications situation that is not linked to the wires, because telecom is in the same situation as energy. And when you have power go down in a city and you've got people that are needing emergency services, communications is what you fall back on. So that's kind of what we're doing right now to bridge the gap with Select Power, is looking at how do we kind of bypass the interconnection process with either, depending on the peak shaving, as long as you're not wanting to push back, the connection process is a lot faster, because all you're doing is helping the utility understand what their demand is going to look like, and that you're going to be using less demand during a certain time. But if you're going to be trying to do bi-directional and sell power back to these independent power producers who then get into a power purchase agreement with the utility, it becomes a much more complicated process and much longer. So I think off-grid, or islanded, as they like to call them, islanded microgrids. They even have little islanded microgrids that are transportable for EV charging. For fast EV charging. Certainly.
Well, I think you started answering my my next question is, what do you see for the future? Which of these scenarios will happen, and at what rate?
Well, I think that we're going to be stuck in a position where we're not going to make the goals that have been set in place. I think companies are going to see and need to budget for, which is unfortunately gets passed down to the consumer, which is you and I. The increased cost in power for reliable power, because I think there's going to be about a 5-year, maybe a little bit more, 5 to 7 year gap where power is going to cost us a lot more until we get through this transition. I think hydrogen fuel cells have a lot of promise to them. The price needs to come down. But I think based on what I know with even our, methane production, which methane's even worse than carbon. But when we look at landfills and things like that, utilizing that methane to convert it into hydrogen, fuel cells. And then also a lot of the power plants that are dumping power because they're running at a low load. That's that skipping gear thing I was talking about. Rather than coming all the way down to cold, they're staying at the lowest load they can go without tripping a gear or without tripping without tripping the unit. So they'll run it as low as they can, but they're producing excess generation. So they're utilizing that generation. Some of them are doing modifications to their unit to utilize the excess power to convert into hydrogen. So I think hydrogen has, great promise, but it's too expensive and too volatile right now. So that's why I think there's still a little bit of science that needs to go behind it. But that, or just the price needs to come down. That means we need to utilize it more. But it's super green, depending on which type of hydrogen fuel that you're using.
Sure, certainly. So, how about what recommendations do you have for developers of DER and other energy sources?
I would. It all depends in which energy market you're in and which interconnection market you're in, and that's what's vital for everybody to understand. This is an economic discussion now. It's not it is still environmental, so I don't want to get people upset about that. But it is still an environmental discussion, but it has become more of an economic discussion, because if businesses go out of business because they can't afford to keep the lights on, that's going to affect us all, right? It's going to affect us all. So economics of everything as far as moving forward, I believe the best thing to do is island. And there's completely off-grid, or there's islanded where you're not pushing energy back onto the grid. You're just peak shaving. You're just utilizing the renewables when you can, and then utilizing the centralized when you're not utilizing your renewable. But it's all based in smart sensors, and that opens up another door to the security of things. So that
certainly we can go down that road a little bit. You had talked, your focus is certainly on generation, transmission, distribution. On the retail end, many of the topics that ARC has touched in the past are about those mobile energy sources known as electric vehicles that might consume power at one physical location at one point in time, and later in the day they might be trying to sell power at another location, and that greatly increases the calculus required to solve the issue.
I just hosted, not to interrupt you, Jim, but I literally just hosted a panel for IEEE and it was an IEEE. I'm trying to remember if it was a microgrid consortium or IEEE, but I had a panel discussion regarding that exact topic, EVs and the bidirectional, I think they're called DCs or something. I don't know. Like I said, I'm not an EV person, but there's only a handful of vehicles right now that can push power back on the grid for selling power, but they're few and far between, and the amount of power that they can sell back to the grid is very, very, very minuscule. So to me right now, one, if you would only want to be doing that if you're a fleet, like if you have a fleet of buses or rental cars or something like that, where you're getting kind of a return on your investment from what because the EV cars are more expensive, let's face it, right now, than our legacy cars are. So that too will shift, but we are far away from the technology on that. I think right now the fire they're trying to put out, the utilities and the commission, is how do we deal with the demand of a certain time of day all these EVs are plugging in, and because they're under 500 megawatt or 500 kilowatts, they don't have to get involved with a power purchase agreement or an interconnection agreement. You can just plug your car into your garage. You know what I mean? I'm not really sure on the fleets. Like I won't speak about things.
Yeah, I mean, in layman's terms, we typically, you can, just as an example, you might have one transformer powering 3 or 4 homes, but an EV charging represents the load of perhaps one entire home. So if you and your 3 or 4 neighbors all have EVs, you're going from 3 homes on the grid to 6 homes on that same transformer, and that's not going to work.
Right. And who's monitoring that?
Exactly. So there's a number of philosophies there that are, I know, under development, about there might be some arbitrage on that one transformer where you might be bidding against your neighbor about how fast you can charge your car. I know one of the complications for vehicle to grid applications today is the warranty itself on the battery pack of the vehicle.
Right.
You very often have a warranty for only so many discharge cycles.
Right.
And you can't just do that daily arbitrage of buying power at night and selling it back at 3 p.m.
Right, exactly. And it's the same thing with our legacy units. It's that discharge, it's how many times are you cycling your battery, and you can't use the entire battery. I think you get down to 60% or something like that, and the battery is like no good. So before, it's kind of the same. It's the same with our battery, any kind of battery. You discharge it too much and you're SOL. There's a lot to pack in, and that's the whole problem. Is there's so many variables involved in this transition that, again, I think the basis is our transmission, distribution, sensors, and substations of managing that power. Somebody needs to be in control of that. I believe it's the utilities. That's just, a lot of people don't like that comment, but I think that we need to keep the utilities viable so that we have a hall monitor. Yeah, at least a hall monitor. And I think in the meantime, the bridge, as I'm going to call it, is high performance hybrid microgrids that you can island and not necessarily look to sell back. If you're going to sell back, just be prepared for a long haul approval process. So.
Well, Pamela, this has truly been fascinating, and we're nearing the end of our time together. Do you have any last comments for our audience today?
I guess my last comments are just, let's all do what we can do, and let's be prepared, because there's nothing worse than putting out fires. Like, who is the bear out in California that is the bear that, says don't create a fire and have to put it out, like be a firefighter?
Smokey the Bear.
Smokey the Bear. Thank you. I was drawing a blank. Be a preventer of fires. And in this instance, when I say that, I'm talking about energy. Open your eyes to what's coming. Be prepared for it so that we're all not just sitting around on our hands going, now what do we do? Because it is going to get worse before it gets better. And with any transition, I mean, we have, and I say this all the time, even though it's painful, but sometimes the most painful things have the best, sometimes they're wrapped in ugly wrapping paper, but it's the best gift on the inside. So, you just don't want to be caught not prepared for it. And so just do your part, speak up, speak out, which is what you guys are doing on here. And what I was going to say is we have the opportunity. And this is it's an amazing opportunity when you think about all the revolutions that we've gone through to get where we are today in life. So I don't know, you want to name a couple of them? We've gone through revolutionary wars, and we've gone through civil wars, and we've gone through the Industrial Revolution, and we are still in a technology revolution. I believe that's part of this whole transition, but we're in an energy revolution. We're in we're changing the way we do business. I mean, there's all these revolutions that are happening. They're happening exponentially. And you and I and anybody else in this industry gets to be a part of making this transition and this revolution be either harder or easier, but we get to be a part of it.
That's great. I can't think of how to end on a better note than that. Okay. Again, our guest today has been Pamela Hamblin of Select Power Systems, and she has talked to us in depth about the energy transition in terms of generation and transmission and distribution. So Pamela, thank you again very much for joining us today, and we look forward to seeing you again in the future on the Sustainability Podcast. Thank you.
Thank you. I sincerely appreciate you letting me just chat, but hopefully it was helpful to somebody out there. So.
Well, thank you. And to our audience, we look forward to seeing you on another episode of the Sustainability Podcast very soon.